The mean is the average of the sample size. Now, variance is the sum of squared deviations of n measurements from their mean divided by n minus 1. And you're probably asking why n minus 1 instead of just using n? Well, if you have a large population of n greater than 30, you can use n as there's practically little difference, but for small samples, n minus 1 represents a better or more accurate estimate. The standard deviation is simply the positive square root of the variance. Think of it as square root of variance equal to standard deviation. And I'll draw a little standard deviation symbol right there. Now I have drawn a bell curve below, and what we do in this normally distributed bell curve is we take the mean and we stick it in the middle. That is our average there. And this standard deviation symbol I've drawn right here, one plus or minus 1 standard deviation is going to be somewhere in there from the mean, and we put it up right there. Now that covers approximately 68.27%, or we say 68.3% of the data that a normal distribution sample would have. Now if we go plus or minus 2 standard deviations, we increase our coverage to 95.45%, or approximately 95.5%. And if we go plus or minus 3 standard deviations, we're going to cover 99.73% of the data, so almost all of the data on both sides of the equation there. And then anything past plus or minus 3 standard deviations would be considered an outlier or a fat tail or something weird like that. Now let's take a look at an example here of how to do that. In this problem here, you might want to hit pause for a second, and then we'll figure out how to do this. Okay, in this example, we basically have a class of 30 students, and we got 80 out of 100, and we decided to figure out what the class average might be, or take a random sample. And we decided to ask 5 different students. They give us answers of 55, 92, 67, 73, 77. Okay, we want to know what the standard deviation of our sample is, and we'll include our 80 in that. Okay, well, first we need to know the mean. So that's the average of the sample size. Well, we have these numbers right here, and we will take those numbers and we will add them all together. So we add all those numbers together, and we get 444. Okay, and the next thing we have is, okay, well, how big is our sample? Well, it's 1, 2, 3, 4, 5, 6 people. So we take our 444 number and we divide that by 6, and that gives us an average of 74. And that is our mean. Okay, now we need to figure out this variance part right here. Okay, well, to calculate the variance, we're going to take the difference between the numbers we actually have and what the mean is. So we subtract 74 from each one of these individual numbers we have, and that gives us 6, negative 19, 18, negative 7, negative 1, positive 3. And that is the sum of, now we need to do the sum of squared deviations. Well, that is just deviations, so we need to square those numbers. So 6 squared is 36, negative 19 squared is a positive number, 361, 18 squared is 324, negative 7 squared is 49, negative 1 squared is 1, and 3 squared is 9. And we add all those numbers together, and we're going to get 780. And now the next step is we need to divide that, because the variance is the sum of squared deviations of n measurements from their mean divided by n minus 1. So we divide that by n minus 1, and our n number was 6, if you recall earlier. And okay, so we divide that by 6 minus 1. So our variance is going to equal 780 divided by 6 minus 1, or 780 divided by 5. And in this case, that's going to equal 156. So now that we have the variance, now we just need to figure out what the standard deviation is. Now, if you recall, our formula for standard deviation is square root of variance. So we take the square root of variance is equal to standard deviation. Alright, we take the 156 number and we take the square root of that, and the square root of 156 is equal to 12.49. And our standard deviation of this sample size is 12.49. And 12.49 is our answer. Now, if we wanted to figure out where 2/3 of the data went, about 67%-ish, what we do is we'd go, okay, we have a 74 average, and then we'd say plus 12.49, so it would be 86.5, and then 61.5 on the other end, and that would cover, so scores from 61.5 to 86.5 would cover approximately 2/3 of the student scores, if assuming a normal distribution curve. And this wraps up our tutorial for how to calculate standard deviation. Thank you for watching.